Okay, so this is chapter one's project. We're going to be looking at part B and C. To get us started, you will notice that in part B, assuming you already have your original function created, for part B, you're going to take the original function that you created and shift it down 4 units and 3 units to the right. And then what you're going to do is show me the new equation and also show me the graph that it has been shifted and state the new domain and range. So let's get started. Let's get back to Desmos. Now I had my two equations saved here, as you can see. If you don't have your equation saved, you're gonna have to retype it in. So what I'm gonna do now is unhighlight those by clicking on the circle buttons. And what I'm gonna do is create my third equation. Basically, I'm gonna take the first equation, copy and paste it there, and I'm gonna take my second equation and paste it there. So these are still the original equation, but what I want to do is shift them. So like it says in the directions, I need to shift it down. And so how many units down? I have to shift it 4 units down. So if I want to shift it 4 units down, you might remember this as looking at the equation and subtracting by 4. So if I do a -4 here, it's going to bring it down. Notice how this curve went down. And I'm going to do the same here for my quadratic. I'm going to -4 on the outside of the parentheses to shift it down. Now, we know, since we're pre-calc kids, we know how to combine like terms. So I'm going to combine these two terms to clean it up and call it -6. And it still does the same thing. And then I'm going to clean this one up and call it, let's see, +2 minus 4 is -2. And so there we go. And so now I also need to shift it horizontally to the right, I believe. Yes, it says shift to the right 3 units. So in this case, what you want to do first is go back to your domain first. So this is your x value or your domain, and you have to shift everything to the right. So when you're shifting to the right, notice you're adding 3, right? You have to add 3 to these x values. So I'm going to add 3 to the -2. Basically, I'm going to increase all the x values in the interval by 3. So this would end up being -2 plus 3 is +1. 2 plus 3 is 5. 2 plus 3 is 5. And 5 plus 3 is 8. And so notice I've now shifted everything. And now my graph looks like really wonky. They're not even connecting. Well, that's because I haven't shifted the actual function. I've just shifted the interval. So like the cutoff points. So what I have to do to shift them is, you might remember back in Journal 3. So when we cover Journal 3, you will notice if you want to create a shift to the right, you have to do a minus sign inside the parentheses. So let's take a look at our equation. So our quadratic's pretty easy because it has a parentheses already inside, so all we have to do is shift it to the right by 3, so I'm just going to put a -3. And I'll clean this up a little bit, so -2 minus 3 is actually -5. So I've shifted it, and notice that that piece now looks very similar to my original quadratic. It kind of looked like that piece. In fact, I'll show you guys. So this was the original picture. Notice how that quadratic looks like that shape right there, that halved parabola. And that's what it's starting to look like here too. So what I have to do is get this piece to connect right there. But in order to do that, I need to shift this to the right. So also, I think I made a mistake here. Did I subtract by 4 here? Yes, I did. Yes, I did. Okay. So now I'm ready to go. So what I'm going to do now is also, so forget what I just said 2 seconds ago. Essentially, the next thing I want to do is also shift this by 3. And to do that, I have to force this to have parentheses. So force the x to have parentheses and do a -3 on the inside. There we go. And I have now my new equation. Now, some people, they might clean this up a bit and actually distribute that in and get their equation. You don't have to do that, but you can clean this up and figure out what it is after you distribute the two and combine like terms. But I'll just leave it like this. So once I'm good to go, I have my equation now. I'm going to screenshot this image and my two new equations that have been shifted. So I'm going to grab my command for shift and screenshot these two equations. And I'm going to screenshot this equation. Make sure you get the whole equation in, or else you're not going to be able to tell the domain and range. So I'm going to do my best to make sure I have everything in this picture. And now I'm going to go to my Google Slides, and I'm going to paste in, let's see, what did they want in the rubric? They want the equation, so I'm going to put in the equation. So I'm going to put image, upload, and now it's already on my desktop, so I'm going to go to my desktop, and there it is. Paste that in. Ooh, that's a little too big. Let's squeeze that down a bit and pop that in there. So that's my equation that I want to see. Like I said, you can simplify this guy if you like. But I'm just going to do this pretty quick. And I'm going to upload my image. Ooh, that's a little big too. Let's squeeze that down a bit. There we go. And so now all I need to do here is, let me type down my domain and range. I need that. So my domain here is going to be basically my intervals, like what was the furthest x value that it went outwards. And so notice how my domain, the lowest number on my domain out is 1, and you can definitely see that on the graph if you trace it. The furthest x value out is 1. So it starts at 1 with a bracket because it does touch it at 1. And then the furthest to the right that it's extending is right there at x equals 8. Notice right there is x equals 8. And close that bracket. There we go. And then what we need to do is our y values, the range. So the lowest y value here is down here at -10 for me. So this is going to be different for me compared to you guys. And then up here is the highest y value. And it looks like now the y value is at, let's see, 6, 7. Looks like it's at 7. And I'm going to close that parentheses there. And there we have it. So now you have your equation, your graph, and your domain and range. So next, we are ready for part C, which is reflecting over the x-axis. So to reflect over the x-axis, what we're going to do is, again, we're going to take the equation, the original equation, and we're going to shift it. So first, let's go back to Desmos, and I'm going to unhighlight these and basically copy and paste the original. So I always go back to the original and paste that in, or you can type it out, whichever is easy for you. So here's my two new equation that I'll be using for part C. And, oh, sorry, this one was meant to be the parabola. Let me copy and paste that again. There we go. So this is really my original function, but I have to reflect it over the x-axis. And if you look at Journal 3, you will notice to reflect something on the x-axis here, you have to negate it or put a negative sign outside of the equation. And what that means is you're distributing a negative sign to each term. So let's take a look at our equation for a sec. If I am putting a negative to each term, that means this 2 becomes a negative, and then this 2 becomes a positive. Oops, meant to write a positive. So essentially, when you compare these two, right, I just negated or flipped the signs of each term. And I'm not going to change the domain because it didn't say I have to do any shift that's horizontally, so I'm going to keep this the same. Now I need to negate this one now, so I'm going to make this whole term negative, and to do that, all I have to do is put a negative sign in front of it. And then I have to change, but here's the thing, this negative doesn't distribute to this 2 here because it's outside of the parentheses, so I have to negate that as well. And there we have it. Notice that this graph is actually the reflection across the x-axis of the first graph. Let me graph the other two so that way you can really see it, but notice how those two are basically flipped one another, or they look kind of like a mirror image of each other along the x-axis if you take a closer look. But all we care about is the reflection graph. So again, now we're ready to take a screenshot. So let me Command Shift 4 and get that whole piece in there so that way I can look at the domain and range. And I also want to grab my equation here. So I'm going to grab that and we're ready to go. So we're going to pop this in here. So upload image, and there is my new image, I believe. And so I'm going to make this a little bit smaller so it can fit. And then I'm going to pop in the graph here. So this is the flipped over the x-axis graph. Let me make that a little bit bigger so my eyes are not very good. There it is. And now I'm just, again, going to type in the domain and range. And so for the domain here, we have it at, let's see, the lowest x value was at -2 and the highest value was at +5. And I'll double check my graph, but notice that -2 was my lowest x value and my highest x value was at 5. Basically, the domain didn't change from the original graph because we didn't shift the domain. We didn't shift the x-axis. What we did is change the y values because we put that negative sign into each term. So notice that now my lowest y value is at -11 down here, right? So -11 is my lowest y value. And my highest y value, if I go all the way up here, is 6. So it's like basically the right and left part of the curve got like switched in a way. And that's it, guys. I hope this helped. I also want to give you one more tip about Desmos. If you're having issue typing in these inequality signs, remember there's a keyboard icon here, a hidden keyboard, and you can use the inequality signs and any symbols here to help you out. So that's it for this video. I hope this helped you to complete part B and C. But bye, guys.